students. Let me introduce myself. My name is Naveen Kumar. I am going to teach you mathematics. Children, for ninth standard, I am going to present chapter number system. Children, in this chapter, you're going to learn some basic numbers and we recall what type of numbers we read in the class 8. Okay, so now I'm going to present here the chapter number system. In this number system you can observe the slide. Okay, what you can see from the slide, so there are some numbers, isn't it? Can you recall those numbers? Okay, what type of numbers you've come across in your lower classes? Okay, the first type of number, they are natural numbers. See, here they have given natural numbers, integers, rational numbers, irrational numbers, real numbers, etc. Okay, so here for ninth standard you are going to learn these type of numbers detail. Okay, so introduction. So number system, children, the system where numbers present are called number system. Let us start with a joke. Okay, so what is a joke? Can you see that? Let's start with a joke. Why did the teacher wear sunglasses to schools? Because her students were so bright. Okay, another joke. Why was the math book sad? Because it had so many problems. Okay, another one. What are the strongest days of the week? Obviously, Saturday and Sunday. The rest are weekdays, isn't it? They are weekdays. Then, strongest days are Saturday and Sunday. Yes. Okay. Next. Can you see the puzzle here? Children, we are talking about numbers. Just really very funny that uh, we should love the numbers. Then only we can able to solve this type of puzzle, isn't it? Okay, answer is given. So let us try to understand this puzzle. What you have to do here, you can observe that a star mark in the blank square. You have to fill that star mark with any number. What is that number? You can observe two patterns and fill the third pattern. Okay, what is the first pattern? 5 minus 1. Okay, so I am taking column wise. 5 minus 1 is equal to 16. Is it possible? No, 5 minus 1 is 4. But what is 4 square? It is 16. Yes, correct. Okay, 11 minus 4. 11 minus 4 is obviously 7. Yeah, what is the square of 7? It is 49, isn't it? Okay, so now you can tell me 18 minus what number will give 121? Yes, obviously 7. So when you subtract 7 from 18, you will get how much? 11. What is the square of 11? Is 121. Got it? Okay, so this is how there are many puzzles. When you write the competitive examination or in the exam, you will get these type of puzzles. And it's very interesting to solve these puzzles. Children, many of them you are thinking that mathematics is tough subject. In fact, it is not a tough subject, but if you learn all the things, if you learn the concept better, then the no mathematics is tough. Okay, so in fact mathematics is very easy subject. So here is there Mr. Naveen. He will help you to make maths easy, and he will tell that how to make any problem very easily. You do not have to take worry and hesitate. So first love the subject, then automatically you will be able to solve any type of problems. Got it? So solve these type of puzzles, then you will be increasing your concentration power. Got it? Okay, shall we move to next slide? Okay, so next slide. See children, here one more. I think in the class 8 you have learnt about magic squares, isn't it? They're really magic. Why they're magic? Because you can see that the numbers are arranged like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you need to arrange these numbers so that you can get, when you add row wise, column wise, diagonal wise, get the same answer. Okay, I will give you 1 minute and try to do this, how you can arrange these numbers and get a, so I'll give the answer. Okay, so suppose if you add first row 1 plus 2 plus 3, if you get it, you must get 15. This is a 15 magic square. Okay, every time you should get 15 when you add row wise, when you add column wise, when you add diagonal wise, you must get 15. Yeah, this is a problem of class 8 children. Okay, you might have learned it. Okay, now can you tell me very fast what would be the arrangement, rearrangement of number? Okay, uh, so I'll give answer, no problem. So there are many answers, but you can try it. Okay, so different types of answer you will get it. So okay, you can see the answer. Wow, it's very amazing. See, 276. Now I have rearranged the number: 276 951 438. Row wise, column wise: 294 753 618. Column wise, and then diagonally 654 258. See, when you all add all the numbers column wise, row wise, and diagonal, you will get 15. This is a one arrangement, children. There are many arrangement you can make it. So try to make it different arrangement. You will get the answer. It's very easy. Okay, so you can do it. Okay, children. Now let us see types of numbers. What type of numbers we have learned in the class 8 or in the lower classes? Children, natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Got it? So these type of numbers, you learned it. Okay, now let us see what is natural number. You already know that the counting numbers 1, 2, 3, 4, etc. are called natural numbers. The set of natural number is denoted by n. Thus, n is equal to 1, 2, 3, 4, etc. up to infinity. Children, you can see natural number is always start from 1. Why it is always start from 1? Yeah, you all, how do you count? You count start from 1, right? 1, 2, 3, 4, 5, 6. Suppose when I ask you to count number of children present in the classroom, then what you do, children? You count starting with 1. 1, 2, 3, 4, 5, 6. That is what we call natural numbers. Natural numbers means they are natural, children, and also they are counting numbers. Children, where do we use natural numbers? There are many instances you can give. I'm taking a bank incidents. Okay, bank. The cashier, what he does, cashier, he or she, what is they are doing? They count the cash. That means they always start from 1, 2, 3, 4, 5, 6, like that. Any number of note, they can count from a starting from 1. They never count as 0. Okay, so these are called natural numbers. Wherever you can use counting, where they use for counting, that is called natural number. You can see that. You can also, you remember in your lower classes you have learning by using hands, isn't it? And using the fingers. For example, when you add something, for example, add 2 plus 3, then what you do? You take 2 in a finger and 3 in a mind. 2 and 3, that is 5. Remember? So like that, when we start counting, you will count as 1, 2, 3, 4, 5, etc. They are called natural numbers. Okay, okay, next. Children, here some counting activities. See, you might be knowing this. These are some faces are hidden in the tree. You have to identify the face. I think it's well-known faces. Okay, how many faces can you see in the tree? Okay, You can hear, and visible. Is it visible, children? Yes, visible. You can see that. How many cubes are? Can you see in the black? See in the blocks you have there, isn't it? There many blocks are there, cubic blocks. You have to count that how many are there, how many faces and how many cubes of blacks. Okay, anyway, the video with you people only. You can watch again and tell the answers, and I'll tell the answer in the next class. Okay, so this is what, how do you count? You start with a 1 2 3 4 5 6 etc. Here also number of faces, you can 1 2 3 4 like that. You start from 1. That is what, this is a simple activity for the natural number, counting natural number. Okay, you can also see the wonderful picture in front of you. This picture is the tiger, number of faces of tiger. There are hidden faces, you can see. Tiger has having hidden faces. You must identify and count that, how many faces of tiger you can see here. Okay, see the beauty of the tiger, so how it stands, and what is the dignity of the tiger. Okay, children, nowadays you might be observing that number of tigers are decreasing. Okay, we cannot say, we can say endangered animal. Okay, endangered animals. Tiger is endangered animal because hardly 2000 tigers are present in India. Okay, so we are losing the what we call gene of the tiger. So this is just a counting activity. Okay, okay, so this is how you can count the numbers. So the 1 2 3 4 5 etc etc. Okay, now let us observe that um, the properties of natural number. You already know that. What is natural number? Natural numbers are the numbers which are countable numbers, and also 1 2 3 4 5 6 etc. The least and smallest natural, first and smallest natural number is 1, and every natural number except 1 can be obtained by adding to the previous natural number, isn't it? Yes. For example, if you add 1 to 3, what you will get? 4. If you add 5 6, if you add 1 to 6, you will get 7. That means for the previous number, if you add 1, you will get the next natural number. For natural number 1, there is no previous natural number, remember. Okay, so the previous number would be 0, but that is not a natural number, that is whole number will come later. Okay, got it. There is no last or greatest natural number since they are infinite, isn't it? Natural numbers are denoted by n normally. We cannot complete the counting of natural numbers. We express this fact by saying that there are infinitely many natural numbers. Got it? Next, 0 whole numbers. Let us talk with a whole number. What do you mean by whole number? 0 and natural number together called whole number. 0 and natural number together called whole number, isn't it? So you have 0 there. The number 0 1 2 3 4 5 6, like that, it goes like that. In case of natural number, it will start from 1. In case of whole number, it start from 0 0 1 2 3 4 4 up to infinity, you can see, called whole numbers. The set of whole numbers is denoted by letter W. Thus whole number is equal to 0 1 2 3 4 etc up to infinity. So you know the symbol of infinity. Infinity means what? Infinity means it is undefined. It is not defined, yet it is not defined. Example, you can see, somebody goes to the bank and asks for the loan, and the bank manager says that you do not get loan. Then that means if somebody asks money, if they do not give, what does mean is it's a 0. You have got nothing. You have got nothing. That is what we call 0. So 0 is the natural number. You can find many instances in life as 0. Suppose 0 chocolate, 0, okay, planet, okay, like that. You can take it. That is what we call whole numbers. Next, The properties of whole number. There is no largest last. There is no last or greatest whole number. Initially, what are whole numbers? Whole numbers are the numbers which are whole numbers are the numbers which are start from 0 and end with infinity. There is no last and greatest whole number. There is no largest whole number since they are infinite. There is no largest whole number, they are infinite. There is infinitely many countable numbers of whole numbers. All natural numbers, whole numbers. All natural numbers are whole numbers. Each number is one more than the previous number. All whole numbers are not natural numbers. Example, 0 is a whole number but not natural number. Whole numbers are denoted by double. Got it, children? This is a, you can remember the properties of whole number. Next number is integer. Children, you can see integers means you can observe that 0 in the middle, and the left hand side you can see negative integers, and the right hand side you can see positive integers, and in the middle you can see 0. Okay, so where you can see integers, you can see the negative numbers and whole numbers together called integers. How do we define integers? Negative numbers and whole numbers together called integers. For example, you can see the depth of the ocean can be represented negative. Okay, for example, see the seabed, consider seabed. Above the sea level is positive integers, below the sea level is negative integers. Here the temperature also, you can take temperature. Above the sea, temperature minus 5 degrees centigrade, minus 6 degrees centigrade, minus 39 degrees centigrade, like that. If you say minus degree temperature, then it is a very low temperature. So there you can use integers. 3 meters, 5 degrees centigrade, minus 3 meter, minus 5 degrees centigrade. This is about integers. So nothing. What are integers? Integers are collection of whole numbers and the negative numbers. Collection of whole numbers and the negative number. You can also say negative numbers and the whole number together called integers. Okay. So however you can understand it. Okay. So rational numbers. The next number system is rational number. What do you mean by rational numbers? Rational numbers are the numbers. They are natural numbers, whole numbers, and integers. A number of the form of p by q, where q is not equal to 0, called a rational number. Here p and q are both are integers. For example, minus 5 by 6, 11 by 5, 2 by 15, etc. These are all called integers. Got it, children? So, rational numbers. See, rational number means you always remember it can be expressed in the form of p by q. It can be expressed in the form of p by q, where p and q are integers. Where p and q are integers. Got it? So, this is what we call a rational number. So, some daily life examples of rational number, you can observe that a part of a whole is called fraction. A person height can be measured. For example, is a height of 1.5 meter. 1.5 meter is can be written in the simplest form of fraction, or also mixed fraction, one and a half meter. 1.5 meter can be written in the decimal form 1.5. So if you just see the pizza order, then it will be cut like a fraction, and also you can see the recipe. Suppose something is some cooking is to be done at home, means you will see the recipe. The recipe would be half cup of milk, half cup of 1/4 cup of coffee powder, like that. So this is what in all the situation they use as a rational number. Okay. Then representing numbers on the number line. Everybody knows that. What do you mean by number line? Number line means it is a line which consists of numbers. It is a line which consists of a number. Here you can observe that a rational number can be expressed on the number line, can be represented on the number line. You can observe between 1 and 2, what value is there? Between 1 and 2, 1.5, isn't it? And between 3 and 4, 18 by 5. Between minus 1 minus 2 minus 1 by 3, 0.33 bar, isn't it? So this is what we there in the number line. So in the class 8 you already represented the numbers on the fractions or the decimals or rational numbers on the number line. Okay, so you can observe here natural number. Natural number, how, see, observe the color, blue color. So it starts from 1 2 3, isn't it? It's then, and whole number 0 1 2 3, integers minus 3 minus 2 minus 1, 0 1 2 3. Rational number, you can see in between 0 and minus 1, minus 1 by 2, in between 1 and 2, 1 by 5, in between 2 and 3, 2.8. Like that you can represent numbers on the number line. Then we have a properties of rational number. Children, you observe that there are many properties of rational number: commutative property, associative property, distributive property, identity element, inverse property. So first you will see the commutative property. What do you mean by commutative property? You know that a plus b is equal to b plus a. One example, 2 plus 3 is equal to 2 plus 3 is equal to 3 plus 2, isn't it? For example, what is the value of 2 plus 3? 5. Then reverse it. 3 plus 2 is 5. That means this property is called reversing. Reversing also you are getting the same answer. Reversing and adding also, interchange the number also, you will get the same answer. That is what we call commutative. It holds good for multiplication also. For example, 4 into 3. What is 4 into 3? 12. Okay. So 3 into 4 is 12. Like that. So interchanging the number and you will get the same answer. That property is called commutative property. The second property is associative property. Associative property means you can see the numbers are grouped. If you group the number differently, you will get the same answer. Okay, so for example, a plus b plus c. Here b plus c is grouped. A plus b plus c. In the right hand side, a plus b is grouped. Okay, so means for example 1 plus 2 plus 3. Okay, what is the answer? 1 plus 2 plus 3, what is the answer? 6. Okay, so again 1 plus 2 plus 3 is 6. For example, I will group 1 plus 2 in the left hand side and the 2 plus 3 in the right hand side. If you group it also differently, so you will get the same answer. That property is called associative property. Then we have multiplication also. For example, 1 into 2 into 3, 1 into 2 into 3. Okay, so if you group also, you will get the same answer. Next, distributive property. What is distributive property? A into b plus b. Okay, for example, 3 into 4 plus 5. So you distribute like a 3 into 4 plus 3 into 5. Like that you will distribute. Okay, that is what we call distributive property. Next property is identity element. What do you mean by identity element? Identity element means, for example, if you add 0 to any number, you will get the same number. Example, add 0 to 3. What you will get? 3 itself, isn't it? If you add 0, if you add nothing to a number, you will get the same number. That is what we call identity property. Okay, in multiplication, that is for addition. Okay, in multiplication, if you multiply any number with 1, you will get the same number. It's like a mirror, children. If you imagine that you are holding a number, for example, you are holding 3 and you stand in front of the mirror, then how it looks? It looks the same number, right? Like that. So 1 and 0 are the identity property. 1 is identity property of multiplication. 0 is the identity property of addition. Then inverse property. Inverse property means negative. For example, plus a minus a. I will give examples in number. Minus 3 plus 3. What is that? 0. Okay, minus a plus a. 0. That means same numbers with opposite sign. You will get 0. Next, dividing the same number. For example, 1 by 2. Okay, 2 1 by 2. Then 4 1 by 4. Like that, dividing the same number, you will get 1. So that is inverse property. Got it, children? These are some properties of rational numbers that you have learnt in the class 8. So remember, this property is very important. Next is the chart of rational number. Look at the children, how the beauty of mathematics, how it involves. You can see small circle of natural number 1 to 3. Okay, natural numbers see it in the small circle, and that is covered by bigger circle, that is 0 whole numbers. So, and that is covered by integers -1, -2, -3, and that is covered by rational number 1 to 1 by 2, 0.7, etc. So this is how you can observe. All natural numbers are not whole number. From this you can say that all natural numbers are not whole number. All whole numbers are not natural number, isn't it? All integers are not natural number. Integers are natural numbers. All rational numbers are not natural number. Okay, so like that you can think of. It is very easy to identify the different types of number if you draw a chart like this. Okay, next we have the number system is called irrational numbers. Children, irrational numbers means in the class 8, actually in the class 8 you have not learnt about irrational number. In this class detailedly you are going to learn. Irrational numbers means it is a non-terminating and decimal which is not repeated, that is non-repeating decimals. Non-terminating and non-repeating decimals are called irrational number. The square root of all perfect square are rational. Okay, the square root of numbers that are not perfect square are irrational. Got it? Here simple. What is irrational number? Up to that you have learnt about rational number. Rational numbers are the numbers which can be expressed in the form of p by q. But what about irrational number? Irrational numbers which cannot be expressed in the form of p by q. That is what we call irrational number. Got it? Okay. Now you can see in your daily life how you use irrational number. Pi is considered as a irrational number. So how do you get pi? So you know that a circle, okay, diameter, circumference by diameter, you will get pi. That is a analogy of pi. You can think of pi. What is the difference? What it makes difference? The value of pi. Why it is irrational number? Considered as irrational number. See children, after 3 point decimals, you can observe the decimals, it will be changing continuously and it is not repeating, the same number is not repeating, and that is the beauty of this irrational number. Okay, so it will be completely changing, you will get different numbers. So that is what we call irrational number. So pi is considered to be 22 divided by 7. Okay, so a good example for irrational number, non-perfect squares. For example, root 2. Root 2, the value of root 2 is 1.414, etc. Like this it comes. So you can observe that the diagonal is a value of square root. Got it? This is about examples of irrational numbers. Some more examples of irrational numbers. It's very important that pi is an example of irrational number. Euler number, you can also see that Euler number. You will learn later what are those, and try to find out what are these Euler number and all. Root 2, value of root 2, already I shown that 1.4. Now do you get that? And the golden ratio, it's very important, that golden ratio is 1.6 something. It goes like this, an irrational number. So you can see the beauty of the nature. In the nature, the golden ratio beauty, everywhere you can see that. Okay, that you can find out from the internet, what is golden ratio, how it is very important. Okay, this is an example for irrational number. See children, irrational number, root 2. Root 2 is an irrational number. The value of root 2, 1.414213562309151, etc. See, what is the dot indicates? dot indicates that it will continue. Okay, so that means it is non-terminating. Okay, non-terminating means it never stop. Example for non-terminating, so non-stop bus. When you sit on the non-stop bus, it never stop in any of the stop. It will reach the final destination. That's why we call that is non-stop bus. Here non-terminating means it is never stop. Okay, non-recurring decimal. Non-recurring decimal means recurring means the same number repeat itself many times. It's called recurring. Non-recurring means the numbers will not be repeating the again. That is what we call non-recurring. So here in your mind it should be fixed that what is irrational number. Somebody asks you to find what is irrational number. Irrational number means non-terminating and non recurring decimal is called irrational number, isn't it? It's very easy, right? So root 3 is also irrational number, 1.7320508087, etc. like that. This is also an irrational number. Children, one question for you. Find out how do you get the value of root 2 and value of root 3? Like 1.41. Okay, here value of root 3 is 1.73, etc. How do you get? You just find out how do you get that. I need to know that. Okay, so this is how the irrational number. For example, somebody asks you to give the example for irrational number. What are you going to say? Now all non-perfect square. What do you mean by perfect square? Perfect square means 1 4 like that, 1 4 9 16, etc. They are all perfect square because they have a roots, and here 2 3 5 they are not having the perfect square. That is what we call they are non-perfect square. Okay, so you can give example of irrational number like root 2, root 3, root 5, root 6, root 7, etc. They are all example for irrational. Okay, then finally, so we'll come to the conclusion that what are real numbers. Okay, so children, in the class 9, it's a very important that you should know about the number. That is what we call real number. How do you get real number? Real number adding rational number and irrational number. See, every number present in the one domain. You can see all the numbers are present in one domain, but you can see the difference. Rational numbers are separate and irrational numbers are separate. The irrational numbers are not in the rational number. That is the beauty. Okay, irrational numbers are separate, rational numbers are separate. Finally, what is irrational and rational? Rational means, for example, it can be easily predictable. It can be easily predictable. For example, 2 is rational number. Why 2 is rational number? 2 will be exactly divisible by a 2 and 1. But root 2 is not an, it cannot be expressed in the form of p by q, or it is not divisible. Okay, so we cannot predict the number. What is the after the decimal point, what number should be there? We cannot predict, but we can. It is real only. We cannot predict. It goes on like that. But they are irrational. Okay, real number means what is real number? Real number means rational number plus irrational number. Both are called real number. In another way, the collection of rational number and irrational numbers are called real numbers. Got it? Next, this is a good chart that you can observe that. See, natural numbers, you can small oval shaped, this one purple color, natural number 1 2 3 4 5, whole number 0 1 2 3 4 5 7, integers 0 1 2 3 minus 1 minus 2, etc. Rational numbers are like this, 0.8888. What kind of this number is repeating decimal. You can see recurring decimal, 0.12121212 like that it repeats. 0.25 is stopped, isn't means that is terminated 0.25, no numbers are present in that. Okay, then 9.3 bar, 3.3 bar means that is what we call bar represent 3 will continue, it's repeated like that. You can observe. Okay, irrational number. Finally, irrational number, you can see that pi 7.193, etc. Root 2, root 5, root 77, 150, etc. These are all called irrational numbers. Rational numbers and rational number both are called real numbers. Here is a chart of real numbers. Real numbers can be rational number, irrational number. A rational number can be integers, non-integers, negative integers, whole numbers, non-integers, terminating, recurring. Here whole number, zero, and natural number. Like this, you can draw the map. Okay, so again we'll just see that natural numbers means it is 1 2 3, whole numbers means 0 1 2 3, integers means 0, positive number right hand side 1 2 3, negative number left hand side minus 1 minus 2 minus 3, rational number. So you can see 0 also there, rational number, p by q form, it can be expressed in the form p by q form, etc. Irrational number, irrational numbers are root 2 root 3, see minus root 2 minus 3, etc. You can non-terminating and non-repeating decimals. Real numbers, what is real number? Real number is a rational numbers plus irrational number. Both rational number and plus irrational numbers is called a real number. Got it? Okay, finally summarize. We'll summarize what are the types of numbers. Natural numbers are denoted by n. N is equal to 1 2 3 4 whole numbers. Whole numbers from 0 onwards are known as whole numbers, denoted by W. uh, W is equal to 0 1 2 3 in dots. Dot indicates that it continues. Integers, the collection of all whole numbers and the negative numbers called integers, denoted by Z or I. Okay, so rational number, a number which can be expressed as p by q form, where q should not be equal to 0. Q is known as a rational number, denoted by q. Irrational number, a number which can't be expressed in the form of p by q, and its decimal representation, non-terminating, non-repeating, is known as irrational number. Number line, number line means the numbers can be expressed on the line is called number line. The method of to finding the rational numbers between two numbers p and q. Got it? So this is what we call summary of the what we have learned today. Finally, we have an activity or a activity for you. So now look at the clock. You know already what are the numbers are present in the clock. So you can see that, right? Okay. So tell me the first number. How do you get that? Now you have to work out and tell me how do you get all this number. It's exactly the same number what you have: 12 1 2 3 4 5 6 7 8 9 10 11. So everything is there, but there is a everything is formed out of 9, and addition, subtraction, multiplication with all are rational numbers only. You can see how it can be done. It's very easy. Okay, so you will do it, right? Okay, next homework. The first question: what are integers? um, what are integers? Give an example. Is 0 is a rational number? Justify. Are all whole numbers or rational numbers? Yes or no? Give any two differences between a rational number and irrational numbers. What are real numbers? Okay, so this is what in the homework. Note it down. Anyway, you will have this. Okay, children. You noted down the homework. Okay, so okay children, so here I tried to recall all the numbers, what are the basic things are required to start the lesson. That has been done, and you also recalled successfully what type of numbers were there, and what we have to do next. Detailedly we are going to study about irrational numbers, how to represent irrational numbers on the number line. Everything will be done in the next class. Okay children, okay, bye, thank you.